On our first proper lesson, we're going to start with Newton's first law. And you may remember this from previous years, namely from IGCSE. And this is also called the Law of Inertia, and it says this: an object at rest will remain at rest, and an object at motion will remain at motion in a straight line and at constant speed, unless an external force acts on it. Okay? Think of it a little bit. Think of any situation that you can imagine. For example, me standing right now over here. All right? What is my state of motion? I'm resting. Okay? I'm at rest, I'm not moving. In order for me to move, an external force needs to be acting on me. In this case, if I can decide to move myself, and I will consider the motion of my legs as an external force. All right? So probably a living thing is not the best example, but imagine a box that is standing on top of on the floor. All right. If it is at rest, the only circumstance in which it will start moving is if an external force acts on it. This is pretty intuitive. Now, the other one, this motion, is probably not. All right, because in real life here on Earth, it's very unlikely that you find an object that is moving at constant speed and in a straight line with no force associated with it, because ultimately you will always have the weight of that object, and ultimately you will always have some kind of friction to that motion. But now imagine an object, let's say this pen, in outer space, away from any gravitational field, moving at a constant speed, all right, or moving, all right. If no other force acts on it, it's going to continue moving at a constant speed. There's nothing stopping it, making it accelerate, slowing down, or turning, right? So the law of inertia says that the marker, away from any force field, is going to continue moving in a straight line at constant speed unless something touches on it and changes its direction, or stops it, or speeds it up. All right? That's what the law of inertia says. So implications. If an object is stopped, it will remain stopped. If an object is moving at constant speed and in a straight line, it will continue so, unless an external net force acts on it, and for some reason there is some can't understand very well what's there, unless an external force acts on it and changes its motion by speeding it up, slowing it down, and making it turn. I'm going to correct this, and once you download this, this is going to be readable. All right? This means that if this net force or resultant force, I'm going to use more the term resultant force, and I'm going to represent it by a capital R. Okay? If this resultant force is zero, then the object will be either stopped or moving at a constant speed. This needs to be very clear in your head. All right? Resultant force zero, object either stopped or moving at a constant speed. Reversely, an object stopped or moving at a constant speed means that the resultant force is zero. This needs to be clear, crystal clear in your head. If not, if it is not zero, then the object will be either accelerating, which means speeding up or slowing down, or turning, because the resultant force now is not zero, and you will have an acceleration. So let's say here these examples. You have a car with all these forces applied. The weight is cancelled by the normal contact force, so vertically speaking, there's nothing happening. But the driving force of the engine is bigger than the frictional forces. So you do have a resultant force. The net force over here is this. This is the outcome of just adding all these forces together. It's not a new force, all right? So the resultant force is in that direction. That was already the direction of motion. So if the direction of motion is the same as the direction of the resultant force, it means that it's going to speed up. Second situation, same car, but now the car is, the driving force is that way, but for some reason the frictional forces are bigger than the driving force of the engine. So now the resultant force is in that direction, but the car was moving there. if the resultant force is in this direction, what does this mean? This means that the car will slow down, is in the opposite direction of motion. Now, if you have the direction of motion and the force perpendicular to it, and here I came with the example of the moon orbiting the Earth, all right? So at that particular instant, you can take here the orbit of the moon, but at this particular instant, the direction of the moon is like that. The weight of the moon, or gravitational force of the moon, points towards the center of the Earth. They make an angle of 90 degrees. So what does this make? This make a change in direction. That's the reason why the orbit of the moon around the Earth is pretty much a circle. On the next lesson, we're going to talk about Newton's second law.